And that's where two sides, it's also known as an isosceles right triangle. That's where two sides were the same, and then to get to the hypotenuse, you'd multiply by the root of 2. If I'm looking at this pink triangle, and I want to go from the hypotenuse, which has an x and a square root of 2 next to each other, to one of the legs, how would I do that? Excellent, Tristan. I would divide by the square root of 2. So to go from this 1 in the pink triangle in my circle to the side, I would write down 1 divided by the square root of 2. Now we know in pre-calc we're not allowed to leave things in unsimplified form. And what I'm going to tell you is when you simplify that, that's called the square root of 2 over 2. And I'm not going to go through how to simplify that. We've done that a lot in this class already in the past. You can go figure it out on your own if you don't remember. Notice that because these two triangles, or this pink triangle, excuse me, is a 45, 45, 90 triangle, that means both legs have to be exactly the same. So that means the other pink side is also root 2 over 2. Now the reason I'm showing you that is, when you look at these triangles, this means that the coordinates of the blue dot that I'm putting on the unit circle right now, that location is square root of 3 over 2, 1/2. Or in other words, if I'm standing on the origin, I would walk out in the x-axis direction the square root of 3 divided by 2, whatever that means. And then I would turn and I would walk up 1/2 unit. And that would put me on that circle at that blue dot. In the pink triangle, if I was trying to find the location on the coordinate axes, what that means is I would walk square root of 2 over 2 to the right in the positive x direction, then turn and walk up square root of 2 over 2. Or in other words, the coordinates here are root 2 over 2 comma root 2 over 2. And what I want you to think about as I go to the next stuff that we're going to be talking about are the coordinates that you see in the light blue and the pink triangle. Notice how there's square root of 3 over 2 thing, there's a 1/2 thing, and there's square root of 2 over 2 things. I want you to think about that. So here's our unit circle. And here's what I want you to notice. Look in quadrant 1. What I want you to notice is the first location where it says 30 degrees. You guys see that? Yeah. Do you remember the right triangle that I drew? This one? Oh. The 30, 60, 90 triangle. Do you remember that? The horizontal distance was? No.
X square root of 3.
The square root of 3 divided by 2. Good job. That was about 3 minutes ago. There it is, the x value. See it? Right here. The y distance was 1/2. There it is. X comma y. We talked about one other kind of triangle. We talked about the 45, 45, 90 triangle. There it is. We said the hypotenuse was 1, because this is the unit circle, meaning the radius is 1, just like in the blue. But the two sides were both square root of 2 over 2, because we had 1 divided by the square root of 2. Look at the coordinates, square root of 2 over 2. So this angle is 45 degrees for the pink triangle. This angle is 30 degrees for the blue triangle. All of these locations, all of them, the coordinates are being generated by that two special right triangles. That's it. Notice how in the other one, 60 degrees, what do you notice is the difference between 30 and 60? They're just switched. The x and the y are flipped around. Why? Because the triangle's upside down. If I look at the new triangle, this one, this big angle right here is 60, and this one's 30 instead of the other way around, instead of the 60 being over here. So you just flip the coordinates around. Okay, and that's what I want you to notice, number one. Secondly, I want to tell you something really important. In pre-calculus, it's really important to understand that we're going to be talking about coordinates like x comma y But you need to understand that that is also referring to, when you deal with pre-calculus and the unit circle, the cosine of the angle and the sine of the angle. Or in other words, if I were to look at the cosine of 30 degrees, the answer would be the square root of 3 over 2. The cosine of 30 degrees is the square root of 3 over 2. Because the cosine is really the same thing as the x value. The sine of 30 degrees is 0.5, or 1/2. Because the sine is the same exact thing as the y value. So cosine is x, sine is y. This is extremely important. You should write that down if you haven't done so. Remembering that math is a study of patterns, here's what I want you to notice. On the axes, if I look at all the coordinates on the axes, everything has zeros and ones. Positive or negative, but zeros and ones. Everything. I went out 1, 0. I'm at 0 degrees, 2 pi radians. Okay, or 0 radians if you wanted to, I suppose. So all the coordinates are zeros and ones and negative ones. All of the angles for degrees are the 0, 90, 180, 270, 360. That's usually not very difficult for people. And we know how to convert degrees into radians, right? We already learned that. So that won't be an issue for anybody. Whatever you want to go to, put that on the top. We learned that yesterday. Okay, but the big thing about the coordinates that I want you to see is that they're all zeros and one things. Second pattern. Look at the things that are closest to the x-axis. How many degrees are they away from the x-axis? 30. Every single one of them is 30 away. So if you know that you're here at 0, the first one's 30 degrees. If you know that this is 180 and you're 30 degrees away, above it, that's 150. If you're below, it's 210. If you're below 0 or 360, 30 below is 330. Remember, because we go counterclockwise. Okay, that's a pattern. Look at the ones that are closest to the y-axis. How many degrees are they away from the y-axis? 30. And how many are they away from the x? 60. So it's either 30 or 60, whichever way you want to remember it. But those are all 30 off of the y. Okay, so 30 off the x, 30 off the y. The ones that were off the x-axis, the ones that were off the x, I want you to notice something. In the green, notice how all of them are pi over 6 things. Did you notice that?
Yeah.
All the green highlights are pi over 6 angles, if that helps you. Notice that the blue ones, which are closer to the y-axis, are all pi over 3s. 1 pi over 3, 2 pi over 3, 5 pi over 3, and, 4 pi over 3 and 5 pi over 3. 1 pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Okay, notice those patterns. And the last one I want to point out is when you look at the things that are all exactly in the middles, those are all pi over 4 kind of things, and they're all 45 degrees away from any axis. Okay, don't write down any of these patterns yet. We'll do that later. Now, I want you to look in quadrant 1 only. Focus your attention in quadrant 1. This is the only quadrant I have memorized, because everything else is exactly the same. Let me show you what I mean. Look at the green pi over 6 coordinate, root 3 over 2. Look at the next green coordinate. It's a root 3 over 2 and a 1/2 the same, isn't it?
Negative.
Just negative. Why is it negative first?
You're in quadrant 2.
Because you're in quadrant 2, you had to go to the left before you went up, instead of to the right before you went up. So if you know that all the ones that are next to the x-axis are root 3 over 2 comma 1/2, you can do all the ones, and you just got to change the signs because you know what quadrant it's in. Look at the blues. All of them are the reverse of the greens. So instead of being root 3 over 2 1/2, they're all 1/2 root 3 over 2s. And then the same rules apply. If you know which quadrant it's in, you know if they're positive or negatives. And all of the ones that are in pink are root 2 over 2s. And again, knowing which quadrant they're in, you can change the sign plus or minus. So I only know the first quadrant, and then I just figure out which quadrant I want to talk about, and I change the sign. So like if you say one of the measurements on the unit circle, like for example, if you say 5 pi over 4, and I go, oh, that's in the third quadrant. I know the coordinates will be negative, negative. So I know it's negative root 2 over 2 comma negative root 2 over 2. Only because I know pi over 4 is root 2 over 2 comma root 2 over 2. So once you start to see patterns, and there are more, but these are the ones in the way I remember it. Now, Mr. Katzenmeier, years ago, had an exchange student, and this exchange student taught him a trick that helped people from this student's country remember all of these things, like the coordinates, as an example. Let me show you this trick. I'm going to pause here, I'm going to put it on the chalkboard, and then I'll post it on the whiteboard. So in the hand trick that I learned from Mr. Katzenmeier and his exchange student, is if you look at the back of your right hand, remembering that when you're looking for coordinates, the first part's x, the second part's y. We've talked about how it's cosine and sine things. The comma is representing your bent finger. So for example, if I wanted to talk about pi over 6, I would bend my pi over 6 finger, which is the ring finger. I would see 3 fingers to the left of the bent finger, 1 finger to the right. You put those numbers in your coordinates. It's always over 2, and take the square root of the top number. And it doesn't matter which quadrant you're in, because we've already talked about all you need to do is figure out which quadrant you're in, and then after that, you just change the signs in the coordinates to match the quadrant. So this is called the hand trick, or what I call the hand trick. Again, it is not something necessary for you to memorize. It is something I have memorized, and I'm really fast at finding coordinates, knowing what the radian measure of the angle is that way. So on your unit circle test, again, there are 16 locations that you'll be responsible for. 3 things at each location: coordinates, degrees, and radians. If you make any errors, a sign error, forgetting a square root, forgetting to put it over 2, forgetting a parentheses, a comma, whatever, you're going to start from scratch. Okay? So what I'm going to tell you is, the number one thing that you want to make sure that you do is memorize this unit circle. Our test that's actually next Thursday is a 2-part test, right? Calculator, and this is the non-calculator. Here's what I'm going to do for you. If you feel ready to take this non-calculator portion, I'll let you take it whenever you want to. So if you're ready tomorrow, could you memorize it tonight? I'll let you take it tomorrow. Whenever you're ready, you take it. So the goal for tonight is you're going to memorize the unit circle.